For this first example, we're going to take a little bit different of an approach in filming this one, just because there is quite a bit of writing for this rather large basis set, or to check this set. So the first set that we're given is this set of 4 3x3 matrices. And so we're going to determine, or we want to know if the set is linearly independent. Okay, so we're going to call each one of these like a vector, right? So we're going to call each one v1, v2, v3, and v4. And that's going to help us to determine if there is a linear combination of vectors, or that if there exist constants such as this linear combination either equals 0 explicitly with all the coefficients being identically 0, or if we can write one of these vectors as a combination of the other vectors with some constants. Okay. Specifically, what I'm looking for is something of this form. So I'm looking for something that has a c1 times v1, a c2 times v2, a c3 times v3, and a c4 times v4. Now the difference here is that because these vectors in this form are actually these matrices, that means that each one of these elements is going to be multiplied by one of the constants. Okay, so for the v1, it's going to be each element is going to have a c1. For v2, each of the 9 elements in v2 will have a c2. Likewise for v3 and c3, and c4 and v4. Okay, once we multiply all of those out and combine like terms, remember adding matrices component-wise, we're going to get a matrix that looks like this. Okay, and we're still equal to the 0 matrix. And so what this produces is 9 equations with a total of 4 unknowns. Okay, 9 equations coming from each element in the matrix. The result, if you recall, is that in order for this to be equal to 0, that means element-wise, the 0 matrix that is here, each element here is identically equal to 0. So we're comparing each one component-wise exactly equal to 0 with our 9 equations and our 9 unknowns, okay, which allows us to do a row reduction if we create the augmented matrix. We did this in GeoGebra, so we put this matrix into GeoGebra using the row reduce form, and we were able to get out this matrix here. Okay, and that produces then the corresponding relationship that C1 is equal to the opposite of C3 plus C4, C2 is equal to 2C3 minus C4, and then we have 2 parameters, or 2 free variables, C3 and C4. So we're going to let C3 equal S and C4 equal T. Okay, and in doing so then we can finally state that not only is this set of our original set linearly dependent, we can write the null space in the form of C2, C3, C4 is equal to S times negative S1, or S, sorry, and plus T in this form. Or another way of saying that is that V2 and V3 are written as a linear combination in that form. All right, I hope that was helpful, and I'll see you in the next video.